Alright, the next tutorial is over the kinematics freefall. So, questions 1, 2, 3, and 4, you should have just been able to give the height above the Earth's surface, so you should have the appropriate scale, which would be 5, 10, 15, 20, 25. Then for number 2, you're going to plot the data points for the height, and you should have had a curve that curves up in this general direction like this. And then for number 3, draw the line for the best fit curve, and for number 4, using your graph, determine the speed of the mass after it has fallen vertically for a distance of 12.5 meters. So if you went from the 12.5 meters and you estimated the height for the speed, you should have got somewhere about 15.5 for your answer. Okay, question number 6. A rock falls from rest at a vertical distance of 0.72 meters to the surface of a planet in 0.63 seconds. The magnitude of the acceleration due to gravity of the planet is, and it gives you choices. So when we're dealing with this, there's the one very simple equation that unfortunately is that distance equation based off of the acceleration though. And so again, there's not a really good helpful list here. When you're talking about acceleration due to gravity and determining the distance equation would be 1/2 a times t squared. Which is essentially the same derivative of these problems. But this is a more simpler version of that for you to have, and I don't mind if you write it down on your equation sheet, and I might even let you use this particular equation sheet for your test. Okay, so distance equation, question number 6. A rock falls from the rest a vertical distance of 0.72 meters. So we know we have a distance of 0.72 meters to the surface of a planet in 0.63 seconds. The magnitude of the acceleration due to gravity on the planet is, so we want to know what the acceleration is. So if I use distance equals 1/2 at squared, we should be able to determine that. So distance is 0.72 meters, which equals 1/2. Acceleration is the unknown times time squared, which is 0.63. Okay. So if I have the 0.63 squared, that gives me 0.2. 0.63 squared times 1/2 is 0.2, and a for acceleration, which equals 0.72 meters. So that gives me 3.6 meters per second squared. And so your choice should have been choice number 3. Alright, next would be question number 14. Question number 14. A ball dropped from rest falls freely until it hits the ground with a speed of 20 meters per second. The time during which the ball is in free fall is approximately. So for 14, you have to know that gravity is 10 meters per second squared. So if we know that gravity is 10 meters per second squared, aka 9.8 meters per second squared, that means that we know that for every second that passes, it gets 10 meters per second faster. So if it was falling for if it has a speed of 20 meters per second, that means that it was falling for a total of 2 seconds. So your answer should be 2. Okay, question 17. How far will a brick starting from rest fall freely in 3 seconds? So again, it's kind of the opposite. If I know that it's falling for 3 seconds, that means it should be going about 30 seconds. But again, they kind of go back from 10 and 9.8. So if it's falling for 3 seconds for 17, we know that the answer should be the closest to 30, which is 29 meters. And if you have any questions about any of these, make sure that you ask during class.